So let's begin our steelhead configuration. The first thing we'll need to do is to get the server-side steelhead to join the domain. To do this, we'll first add a DNS entry on the Active Directory server for our steelhead. On the server, start DNS Manager and click to add a new host. Enter the host name of the server-side steelhead and the IP address. On the server-side steelhead, go to the host settings and add the IP address of the Active Directory or DNS server and enter that as your primary DNS server. Next, go to Networking, Windows Domain. Enter the domain name, login, and password. In this case, we're using the administrator credentials, but you really should create a username and password on the domain controller for the steelhead, and you should use that username and password for authentication. Once you have everything, click on Join. You should now be successfully registered on the domain. Next, we'll add the delegate user information. Go to Optimization, Windows Domain Auth, and enter the delegate username and password on the domain. Select Auto Delegation Mode and click Apply. The configuration above only needs to be done on the server-side steelhead. Now, let's enable Outlook Anywhere optimization. This needs to be done on both steelheads. Go to Optimization, MAPI, check the Enable MAPI Exchange Optimization checkbox. Within that, enable the Outlook Anywhere connections. Also check Encrypted Optimization and select Delegation mode. The steelheads offer some messaging around needing to join the domain and adding the delegation user. We already did this for the server-side steelhead. However, you can ignore this message for the client-side steelhead. Apply all changes, save the configuration, and restart the service. Let's now tackle SSL encryption. The first step here is to import the certificates from the Exchange server onto the server-side steelhead. On the Exchange server, we open up IIS Server Manager. Select the server name, find the entry for the server certificates. In here, you should find the CA cert for the domain as well as the SSL certificate for the server. Export both of these certificates onto the local machine. Note that the export of certificates is in PFX format. On the steelhead, go to Optimization, Certificate Authorities, and import the CA certificate for the domain here. Click Add New Certificate Authority and browse to the location where you saved the certificate in the earlier step. For certificate authorities, steelheads cannot import PFX certificates, so you will first need to convert it into the PEM format. You can use OpenSSL on Windows or Linux to do this. use the following command to convert the certificate. Once the CA certificate is imported, click on the Optimization SSL Main Settings page. Enable SSL optimization and add a new SSL certificate. Here, select the certificate of the Exchange server. PFX certificate import should work just fine here. The next step is for the steelhead to trust each other's self-signed certificates. To do this, start an SSL encrypted session from the client to the Exchange server. In our case, we will open the browser and point it to the HTTP server running on the Exchange server. Go to the steelhead and verify that you see the SSL connection under Current Connections. You should see this connection go pass through with an SSL inner failure. Go to Optimization, Secure Peering. Here you should see the SSL peer gray list, and you should have an entry for your peer steelhead. From the drop-down menu, select Trust. This should move the peer to the whitelist, and the trust is established. Repeat the procedure on the other steelhead as well. Now retry the HTTP session that we tried before and check current connections. This time the connection should go through optimized. Finally, let's open Outlook on the client and check if we can establish a successful connection. Once the connection is established, check the connection status and verify that the connections are using HTTPS. Also confirm this on the steelhead by checking the current connections. You should see all connections show up on port 443 and the application should show up as encrypted MAPI. You now have a successful Outlook Anywhere deployment using HTTPS and encrypted MAPI. In our testing, we had the following test parameters. We were sending an Outlook email message with an attachment of 6.2 megabytes across a 1.5 megabits per second WAN link. The round-trip time between the data center Exchange server and the client at the branch was set to 100 milliseconds. The email was sent from a branch user to another branch user. The first graph illustrates the time taken to complete the transfer. This was improved by a factor of 7, taking the time to send the email and receive it from 2 minutes down to under 20 seconds. The second graph illustrates a bandwidth reduction. Here we see a total of 12.5 megabytes sent over the WAN link with no steelheads, reduced to 230 kilobytes in the warm run. Let's have a look at the most common setup issues and how to troubleshoot them. The most common issues while setting up Exchange 2010 revolve around using self-signed certificates on the domain controller, blacklist of sessions on the steelhead. Once a session is blacklisted, all future sessions will be passed through until the timeout of the blacklist expires. Setting up delegation user and assigning the correct privileges, and finally joining the domain. The most common problem when joining the domain is when the clocks are not in sync between the domain controller and the host joining the domain. Running NTP on all hosts will ensure that this issue will not be encountered. These Microsoft references will be a good resource for better understanding the deployment.